Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and today here we have some questions from A level maths 9709 pure mathematics 3 May June 2021 paper 33. First of all, we have question number 5, question number 1 till 4 I've already uploaded earlier. Now we have question number 5 onwards. So the first question over here is of trigonometric identities and equations. By first expanding tan 2 theta plus 2 theta, show that the equation tan 4 theta equals half times tan theta may be expressed as tan raised to the power 4 theta plus 2 tan square theta minus 7 equals to 0. Now, as you know, the matter of fact that the trigonometric expansion formula for tan a plus b, that is tan a plus tan b over 1 minus tan a times tan b. And if you want an expansion formula for tan a minus b, so that is tan a minus tan b over 1 plus tan a times tan b. So all of these identities and formulas are given to you in the formula sheet in the exam, but it is always recommended to you, recommended that you learn all of these formulas by heart whenever you are practicing the past papers at home, so that in the exam when you have the formula sheet in front of you, so you have an edge over there. Even if you forget any identity, so you can just have a look at the formula sheet and the things would be in your control. But it is always recommended whenever you are doing the past paper practice, all of these identities and formulas must be on your fingertips. All right, so what we need to do, we need to show that this equation tan 4 theta equals half times tan theta can be expressed in this form. And here they have also mentioned a hint by first expanding tan 2 theta plus 2 theta. Even if they don't mention this thing, you would do it by the same way. Okay, so in place of 4 theta, we have to write 2 theta plus 2 theta, and we need to use the expansion formula. So the expansion for tan 2 theta plus 2 theta would be tan 2 theta plus tan 2 theta upon 1 minus tan 2 theta times tan 2 theta. So the numerator over here can be simplified as 2 tan 2 theta, and the denominator can be expanded as 1 minus tan square 2 theta, and this thing equals half times tan theta. Now, since we know that in our required form, we don't have 2 theta, we have only thetas. Okay, so we need to get rid of these. First of all, we need to get rid of this 2 theta over here. We need to get rid of this tan square 2 theta as well. We need to convert it into theta. But right now I haven't mentioned anything further in the steps in place of 1 minus tan square 2 theta, because it is a reason to do so once the whole working on this page is complete, and then I'll explain you why in these steps I haven't wrote anything in place of 1 minus tan square 2 theta. So let's just deal with this thing, 2 tan 2 theta. Now, since we know that the identity for tan 2 theta is 2 tan theta divided by 1 minus tan square theta. So in place of tan 2 theta, I will write the identity over here. So this will be 2 multiplied by 2 tan theta upon 1 minus tan square theta. And then this whole thing is divided by 1 minus tan square 2 theta. And then this equals half times tan theta. Now, these steps which I have performed over here just are for your ease, to make things much more easier for you. Even if you avoid these 2 steps, it's completely fine. As you know, the matter of fact that tan theta over here and tan theta over here will be cancelled out. And this 2 times 2 is 4, and this 2 is multiplied by 4, so it will become 8. So this will be 8 tan theta, okay, over 1 minus tan square theta. All right, and this 1 minus tan square 2 theta will go over here on the right hand side of the equation. So I've just mentioned these 2 steps to make things much more easier for you. In the exam, if you avoid these steps, it's completely fine, no issue in that. So in place of 2 times 2 tan theta, we have mentioned 4 tan theta over here. So 4 tan theta over 1 minus tan square theta is divided by, what I've done is I've taken this 1 minus tan square 2 theta on the other side and half tan theta on this side. So 4 tan theta over 1 minus tan square theta divided by half times tan theta, and this is equals 1 minus tan square 2 theta. So what I can do, I can convert this division sign into a multiplication one and reciprocate this fraction. So 4 tan theta upon 1 minus tan square theta multiplied by 2 over tan theta, and this is equals to 1 minus tan squared 2 theta. Now, as you can see that tan theta and tan theta are cancelled out, and 4 times 2 is 8. Therefore, you are left with 8 upon 1 minus tan squared theta, and this is equals to 1 minus tan squared 2 theta. And as I was saying that even if you avoid these two steps, it's completely fine. You can directly mention this thing over here after this step. Okay. All right. So as I told you earlier that intentionally I haven't wrote anything so far in place of 1 minus tan squared 2 theta because there is a reason to do so. Why? Let me first explain you the reason behind it. As you know that the identity for tan 2 theta equals 2 tan theta upon 1 minus n square theta. Now, by using the same identity, I can also say that 1 minus tan square theta is equals to 2 tan theta divided by tan 2 theta. Okay. Now, since I know that I have 1 minus tan square theta over here, and I want something in place of 1 minus tan square 2 theta. So when I'm multiplying the angle with 2, when I'm multiplying theta with 2, so on the right hand side of the identity, I have to also multiply it with 2, and this will become something like this, that 1 minus tan square 2 theta will be equal to 2 tan 2 theta upon tan 4 theta. And then you will eventually get something in terms of 2 theta and 4 theta. So what would be the need to do all the steps which we have done so far? Things would get a little bit more complicated, so you need to avoid these sort of steps in the exam. So what I can do over here is that in place, since you know that this 1 minus tan squared 2 theta means 1 minus tan 2 theta whole squared. In place of tan squared 2 theta, you can say tan 2 theta whole squared. Now, in place of tan 2 theta, I can write 2 tan theta upon 1 minus tan square theta. And then it is whole squared. So this can be written like this: 8 upon 1 minus tan square theta equals 1 minus 4 tan square theta upon 1 minus tan square theta whole squared. Now, what we need to do, we need to get rid of this denominator 1 minus tan square theta whole squared. So we need to multiply 1 minus tan square theta whole square on both sides of the equation now. So when you multiply it on both sides of the equation, 1 minus tan square theta whole squared. So 1 minus tan square theta, this in the denominator, which is underneath 8, this will be cancelled out. And 8 multiplied by 1 minus tan square theta, and this will be equals to 1 multiplied by 1 minus tan square theta whole squared. So this will become 1 minus tan square theta whole squared, and then minus 4 tan square theta. As simple as that. Now you know what you need to do. Nothing else. You need to just expand the both sides. 8 minus 8 tan square theta. I have used the expansion formula for a minus b whole squared. So 1 minus tan square theta whole squared will become 1 minus 2 tan square theta plus 10 raised to the power 4 theta, and then minus 4 tan square theta. Now, what I can say is that I can arrange all the terms on the one side of the equation, and then 10 raised to the power 4 theta minus 6 tan square theta. As we can see that these two terms can be simplified over here. So minus 6 tan square theta plus 8 tan square theta plus 1 minus 8, and this will be equal to 0. Therefore, you are left with 10 raised to the power 4 theta plus 2 tan square theta minus 7 is equal to 0. And here you get your 4 marks for part A. As simple as that. Then we have part B. Hence, solve the equation tan 4 theta equals half times tan theta for the interval that theta is greater than 0 and less than 180. So we just need to solve the equation in the equation which we have proved in part A, which is 10 raised to the power 4 theta plus 2 tan square theta minus 7 is equal to 0. So when you make tan square theta the subject of the equation, so you have to just use the quadratic formula over here. So minus 2 plus minus under root 2 square minus 4 times 1 times minus 7, and then whole thing divided by 2. So the possible values for tan square theta are 1.8284 or minus 3.8284. This cannot be solved further. There are no solutions to this, no real solutions over here. So no solution to tan square theta equals minus 3.8284. So the possible values for tan theta are plus minus under root of 1.8284, which is plus minus 1.3522. Now we need to solve these two equations, simple trigonometric equations. First one is tan theta equals 1.3522, and the interval is 0 till 180. 0 and 180 both are excluded. So alpha equals tan inverse 1.3522. So alpha equals 53.52 degrees. Okay. And since we know the fact that we are dealing with a positive value of tan theta, and tan theta is positive in the first quadrant and the third quadrant. So in the first quadrant and the third quadrant, we have made the slant lines respectively. And the basic angle alpha always lies between the slant line and the horizontal axis. So 53.52 over here and 53.52 over here. So one possible value of theta would be 53.5. And since we are giving the answers in we are giving the angles in degree mode, so by default requirement is correct to 1 decimal places. So you just need to keep the accuracy in your mind until and unless some other state of accuracy is required. That is something else. So theta equals 53.5, and the other value, which will be 180 plus 53.52, which will be 233.5, correct to 1 decimal place, that will be ignored. And the other possible value of tan theta was minus 1.3522, but when we find the basic angle, we always ignore the negative sign. So tan inverse, again 1.3522, which will give you 53.52. But since this time we are dealing with a negative value of tan theta, and since we know that tan theta is positive in the first quadrant and the third quadrant, so tan theta is not positive in the second one, and the fourth one. Tan theta is negative in the second quadrant and the fourth quadrant. And the basic angle alpha always lies between the slant line and the horizontal axis. So 53.52 over here and 53.52 over here. So one possible value of theta would be 126.5, which is 180 minus 53.52, correct to 1 decimal place. This will be 126.5, and the other one, which is 360 minus 53.52, this will be ignored. Even if you don't mention these ignored ones, it's completely fine. Your final answers are 53.5 and 126.5, correct to 1 decimal place. This is a by default accuracy when you are giving your answers in angles in degrees. When you are giving in radians, so by default requirement is correct to 3 significant figures. But whenever you are giving your answer in degrees, by default requirement is correct to 1 decimal place, until and unless some other state of accuracy, degree of accuracy, is specified in the question. Let's move on to the next one. Here we have question number 6. Part A says that by sketching a suitable pair of graphs, show that the equation cot half x equals 1 plus e raised to the power minus x. This has exactly one root in the interval 0 till pi. So first of all, we need to make a sketch of y is equals to cot half x, and then we need to make a sketch of y is equals to 1 plus e raised to the power minus x. So as you know, the fact that in the cot half x function, the y-axis would be the asymptote. Okay, and here what you can do, you can make a table for finding the values, finding the coordinates, but that is not actually required. That is just your rough work. Your main working is your graph. Okay, so in place of cot half x, you can write cos half x over sine half x. So pi over 2, and you put the value x equals pi over 2, you will get the corresponding value of 1. And then when you put x is equals to pi, so you will get 0. So I've just made a sketch from 0 till 2 pi. I mean, half of the graph is from 0 till pi, and half of the graph is from pi till 2 pi. Okay, but what we need to do, we need to just show that there is exactly one root in the interval 0 till pi. So the graph which is beyond, the graph which is after the value of pi, I've just made I've made it the dotted graph. Even if you just leave it in a smooth way, even if you leave the curve in a smooth way, it's completely fine. What you need to do, you need to just prove that in the interval 0 till pi, you have only exactly one root. Then we have the equation 1 plus e raised to the power minus x, which is a decreasing exponential function, but don't forget the fact that y is equals to 1 will be an asymptote over here, since e raised to the power minus x curve is being vertically shifted upwards. So the translation by the column vector 0 1, so y is equals to 1 will be the asymptote over here. Okay, and as you can see that there is exactly one root. This complete full flash working, I mean your correct accurate graph will give you 2 marks over here. Whenever you are making a graph, don't forget to label the x-axis and the y-axis respectively. For making the graphs, use sharp pencils. Please don't use pen, ink pens, ball pens, whatever. Only use pencils for making the graphs. Okay, and as far as workings are concerned, those are to be given with pens. Let's move on further. Verify by calculation that this root lies between 1 and 1.5. बहुत बोल लिया भाई. So cot half x equals 1 plus e raised to the power minus x. Okay, so first of all, what you need to do, you need to arrange the equation in the form of fx equals 0. Okay, so whatever the terms are, just take them on one side of the equation. So fx equals cot half x minus 1 minus e raised to the power minus cot half x minus 1 minus e raised to the power minus x, and this whole thing is equals to 0. Now, since you know that in the calculator you cannot put this function over here, what you can do, you can use the identity, the basic identity that cot x equals 1 upon 10x. So in place of cot half x, we can write 1 upon 10 half x, basically the reciprocal, I mean by basic, I mean the basic reciprocal trigonometric identity. So in place of cot half x, I can write 1 upon 10 half x and then minus 1 minus e raised to the power minus x, and this whole thing will be kept equals to 0. First of all, in the function fx equals 0, we need to put f1. I mean, in place of x, in place of, I mean, in the input of the function will become 1. So first of all, we need to find the value of f1. So 1 upon 10 half minus 1 minus e raised to the power minus 1. This is giving us a positive value, which is 0.4626. Then we need to put x is equals to 1.5 into the equation. So 1 upon 10, 1.5 over 2 minus 1 minus e raised to the power minus 1.5, and this will be equals to minus 0.1497. Now, since we know the fact that the value of f1 is greater than 0 and f1.5 is less than 0, therefore sign change rule method indicates that the root lies between 1 and 1.5. You need to mention this statement as well. It is always recommended to do by the same way. Then let's solve the part C over here right now. Use the iterative formula x n plus 1 equals 2 times tan inverse 1 upon 1 plus e raised to the power minus xn to determine the root correct to 2 decimal places. Give the result of each iteration correct to 4 decimal places. Now we need to use the iterative form, this iterative form. So xn plus 1 equals 2 times tan inverse 1 upon 1 plus e raised to the power minus xn. Okay, so in order to find the value of x1, let's say x0, the initial value of x, who don't know right now what is x0. Okay, x0 is not given to you over here, but since you know that the interval which we have proved over here in part B1 and 1.5, x0, the initial value will be taken, the x0 will be the midpoint, the mid value of 1 and 1.5, the mid value of the interval which we have proved earlier. Now this initial value can be, this initial value can be referred as x0 as well and x1 as well. It's the same thing. So if you take this as x0, so x0 would be 1 plus 1.5 divided by 2, the midpoint of the interval. 1 plus 1.5 and then divided by 2. 1 plus 1.5 and then divide by 2. This is 1.25. So x naught will be taken as 1.25. So x1, I mean, in order to find the x1, what you need to do, you need to put x naught over here. Okay, so you need to show these steps over here for at least this one iteration, that how you are actually getting the value of x1. And then you can actually make up the whole sequence of the iterations over here. So, but you need to first mention the working. How are you actually finding x1? X1 will be found like this: 2 times tan inverse multiply by 1 plus, multiply by 1 upon 1 plus e raised to the power minus x naught. Okay, so x1 will be equals to 2 times tan inverse 1 upon 1 plus e raised to the power minus 1.25. Okay, so 2 times tan inverse 1 upon 1 plus e raised to the power minus 1.25. So x1, the value of x1 is 1.32149. So correct to 4 decimal places, each iteration must be given. So the value of x1 is supposed to be 1.3215. Now what you need to do, I mean, wherever you are seeing the value of x naught, just mention your ANS answer, the answer function in your calculator. So in place of 1.25, I'm just going to write ANS answer function, and then I'm going to as equals to sign. So the value of x2 is 1.3365. 1.3365, and then again equals to, it will give you 1.3396. So x3 equals 1.3396. Then again equals to 1.3402. 1.3402. Then x5 1.3403. You can give like 4 to 5 iterations or maximum 6 iterations over here, and then you can actually, I mean, check again and again what you are getting. So x5 equals 1.3403, and then equals to. So correct to 2 decimal places, your root is supposed to be 1.34. What x is equals to 1.34, correct to 2 decimal places, will be your final answer to question number. Question number 6, part C. All right.